So we can start. Hi, everyone. Let me introduce you Łukasz Czarnecki. Łukasz is a man of many talents. He's a lecturer, AI architect, and a data science consultant at Amazon Web Services. And this is actually how we got in touch. We run almost all our workload on Amazon, and we've been trying to figure out the best way to leverage AWS services to let our research team to focus on, well, research and data, obviously. So we talked and we thought that others could benefit from our conversation. So we decided to run it as a public session. So we're glad that you joined us here. Some technical notes. This session will last 60 minutes total, including Q&A. We have a hard stop at noon, and it is being recorded. And we intend to publish it, so make sure to smile if you're on camera. And that's it from me. Łukasz, the stage is yours.
All right, thank you, Piotr. Hello, guys. My name is Łukasz Czarnecki, and I am a data science consultant at AWS, as Piotr said. Maybe let me share my screen. I have just, there will be two parts of today's workshop. So I want to show you some slides with our philosophy. So to show you full picture of how we look at data science in production, and also show you some practical examples in code, how we can provide those features. So just let me share my screen. It should be visible right now. Or by now?
Yep, we can see it. Perfect.
But you see PowerPoint presentation?
Just the whole screen.
Okay, but with a PowerPoint?
Yep.
Okay, that's good. This is the one. Yeah, so why we do machine learning is that we have a lot of experience in that. So you know that we are doing many of services that provide machine learning data science features on AWS, but it's all built on our competencies around many projects we do at Amazon. So you see like magazine optimization, you see Alexa here, you see some things like drones for Amazon Prime. So there are many projects that are being developed and where we can learn on the scientific edge of machine learning where we push the boundary. But in AWS, what is more important for us is what we learn from our customers. And this is not a slogan. This is very important of how we develop services. So as you recall the famous words supposedly said by Henry Ford, because it's not clear who said that or if they were said at all. If I would ask people what do they want, they would say that they would want faster horses. And if you imagine what AWS philosophy is like, it is exactly that. So we ask people, what do they want? What do they need? But a part of just asking what do they want and giving them faster horses, we ask, why do you need faster horses? And this is because we want to get faster from A to B, for example. And then we dig deeper and we dig deeper to the exact needs that our customers have. And we build on top of that. So around 10% of our services are built purely on some ideas of, okay, we have the idea that something like that might be useful. And 90% of services, and especially those around data science, data analytics, and so on, are built on our experience with customers. And if you, this is, I think, the most important slide here. When you see here are three layers. So the bottom layer is the infrastructure. So the hardcore one for hardcore machine learning engineers, where you want to use infrastructure, when you want to use deep learning frameworks, when you know everything about machine learning and you want to dig deep technically in the code, you can use the features here, like deep learning frameworks, like access to machines and so on, to inferencia, so inference chips, everything you need. The top layer, so AI services, this is the most convenient layer. So AI services like recognition, like comprehend, so anything you need from speech to vision to text to healthcare, you can use those services easily without any hassle. And of course, this is the what you have to choose, whether you want convenience or ability to customize. So the bottom is customization, but less convenience, and the bottom and the top layer is the opposite. So very convenient layer, very convenient features, but much less customization. And the sweet spot we are building in the middle is our features included in SageMaker. So SageMaker is a full environment. It's not a one service, but many right now, and we still build on top of that, where you get the customization, you get all the features data scientists need in order to build the solution, but also you get many features and services that are already built for you to fit in your machine learning process. So it's built on experience. So whenever data scientists were thinking that, okay, I have to build this model, I have to deploy it, I have to tune the hyperparameters, I have to build a feature store, I have to monitor the model in production, I have to monitor if there is any bias in the model. All those features were built because of experience into SageMaker. And right now, the common thing with data science, with machine learning, is that we do some initial training, we look for solutions, we read some papers, we build some sample code, then we jump into proof of concept. So it doesn't have to be fully working. It can have some rough edges. It doesn't have to be finalized, but we have to prove that it works. But then we have to move to production. And very often, this is a trap, because we think that we can easily just deploy it, use some Flask, maybe containerize, and then just deploy it and it works. But there are many things to consider. And this is where we try to come in and help with that. So common challenges is the data. So where the sources of data that you have to combine to build full machine learning strategy. There are many things connected to skills. So for example, we have in a company many people specialized in NLP, but no people specialized in reinforcement learning or in computer vision. And this is where we can just reuse this high-level services. We can just add some computer vision easily, or personalization, or forecasting, or anything like that, without building a dedicated team for that. Of course, there are business use cases. So sometimes we just try to build something very custom, and also having services which can fit all the spots we are missing can help us to finalize this business case. And the fourth thing that is most common is ML model building, where we can help with make it automatic, with make it faster, and where are many traps also awaiting for us. And something we also try to direct ourselves, so being DevOps ready, because there are also many things to consider as for external requirements, like security, like compliance for some certificates. When we already built our machine learning pipeline, we have to build some workflows, so some red training, some people come in, there is some CI/CD. Of course, there is a huge problem with scalability, which of course, cloud environment can solve. And now just looking at the full picture of how it looks. So usually when we look on the machine learning pipeline, it's just building the model, collecting data, collecting features, then training the model. This is, of course, the most important part for data scientists when they tweak parameters, when they, again, change the data source. And then the deployment. We deploy, and that would be that for like the common sense of machine learning process. But when we look at it from our perspective, there is also a very important part of monitoring the model, because after we deploy it, there are many things we have to consider, like bias, like some predictions that can, like in some cases that we get, for example, wrong input, we can have predictions that can harm our business process. We can have a data drift. We can have changes in the data set coming into our model. We can have changes in the code. We can have changes in the model. So we have to constantly monitor, and according to what happens with our model, it is very beneficial to then come back, train again, and have it all as a process. So again, monitoring part is, again, part of the process, and then often coming also to the first part. So even building it from scratch. But it's not only when something goes wrong, but also when our model is deployed and it's working, we have happier customers, we have more traction coming in, more data points. And often also when we have more customers, some kind of patterns of those users can also change statistically. So again, happier customers mean more customers, more data. And again, we have to come back to the whole process. So it's not only build, train, deploy, it's the full picture in the environment and the full lifetime of our machine learning process. Especially when we start to deploy model, we have also this problem of combining our software development layer with the machine learning layer. There is often this clash of cultures sometimes, that machine learning needs more experimentation, more flexibility, more open ends. And software is more about planning, setting in stone, often setting some processes in order to make it more predictable. And we have to combine it somehow. And this can be metaphorically compared with this. So for example, we've built a house, so we can live in this house. We're protected from the rain. And now somebody asks us, okay, you built the house, so make the same but for 1,000 people. And we see that it's not just scaling this house for like 1,000 times, it's just building something else, because for 1,000 people, it will work differently. This is the same for machine learning models. And when we look at it, we see those three axes of where complexity increases. So delivery model, team size, so more and more people are working on this project, of this data science project, and of course scale. This, of course, this is a place where cloud environment is very useful. So when we talk about the delivery model, is that initially we can just build on one notebook, we can just have one script, we just prototype on our laptop. But then it comes to a point when we have to make it more automatic, when we have to do some CI/CD, some A/B testing, which if they are not considered in the beginning, it can bring us a lot of hassle. If we didn't consider that, we will have to A/B test. And also more and more monitoring and logging, because everybody will want to know how this works in a long time. And we have to consider it when our project progresses. Team size, of course, more and more people coming to the project. In the beginning, there can be one person testing some assumptions, but then there might be more people coming in, and there is a problem of collaboration. And of course, the scale, we have more and more users coming in. We need more infrastructure, scaling horizontally or vertically. and of course, more and more data coming in, sometimes even in petabytes. And the final part is that when we, this is the final slide we have here. This is what we try to achieve in this problem space. So we have those different areas that we have to look after, and we try to see what is happening on the projects we're working on and fit new features in SageMaker which will make life of data scientists, of developers easier. So for example, often there is a case that we start a data science project, but we lack data. So we have ground truth, SageMaker ground truth, that helps to prepare some tagging tools. We have data and we need people to tag it. Ground truth can help with that, because I know it from the past, often there is the case when you have to build those tools in a very custom manner. So we have some building blocks for that. There are, of course, notebooks that are loved by data scientists, but also, for example, MLflow, which is a very cool thing to track your experiments. So we have something similar, maybe not as I would prefer MLflow for SageMaker experiments, but again, this is external tool, and having this environment here, you can also have tracking of your experiments inside SageMaker. There are things like hyperparameter tuning, so you can do it with few lines of code. You can tune few lines of code. You can tune your hyperparameter. You can look inside your training with Amazon SageMaker Debugger. We have many tools right now helping with deployment, also deploying few of your pipelines. So we have right now something like SageMaker pipelines. We have feature store, so you can share your features between models. And again, when you have your model already deployed, we have SageMaker Monitor, where you can look how model behaves in production, monitor if something goes wrong. Also, there is something called SageMaker Clarify, which can monitor against some biases in the model, something very important to consider right now. And also the case I had in my experience that we want to deploy our model, but we are not sure initially if it's good enough. So we want to have something like human in the loop. So model does prediction, but initially we would like this prediction to also be proxied by some human who verifies if this is good, because this goes into production, and we don't want to have anything wrong on production. And this is where we have Amazon Augmented AI. So in every step where we see some hassle, some problems, we try to fit some new features. And also, this is a drawback of my job, because advantage and disadvantage, because I work as a consultant. So I work for AWS customers, and I work on their project. So I'm not, this is kind of a rare situation for me. Usually I'm just building some projects with customers. So in order to make it work, I have to use only things that already work, and and things that I know the value of. So when I also talk about the services, I'm also very sure that those ones I'm talking about really work. The disadvantage of that I'm the hands-on practical person with those services, is that they are constantly changing. So year by year, they are changed, they are built on, and I'm not also on the edge. So probably this picture would be much different with current scope of those services. So we have more and more services here. Okay, this is it for the presentation. Now I would like to show you some example of practical part. How does it look like? So maybe let's start with very common thing, which is deploying models which were built by TensorFlow. This is a very common question. Okay, so I have a model built in TensorFlow because I use some deep learning, some computer vision, something like that, maybe some NLP. And I don't want to have those problems with deployment, to build some containers, to build some Flask applications. I just wanted to make it work. Because we don't have much time, I already went through this code, so I won't be just running this notebook, but just let's go through the code. Let me just make it a little bit bigger. So just let me have a minute to open also the console. And this is a notebook we see, which is part of SageMaker notebook instance. So we run already in the AWS environment. Okay, so here we have some example of a TensorFlow model. One of the based on one of the most popular, so ResNet, a smaller one. So I will be skipping on some very simple code, well, like just defining some paths or something like that. But when you look just on the SageMaker part, so we only have some path to our model. We start our SageMaker. Here we just start the execution role, so we can execute on SageMaker. And from SageMaker, we just import TensorFlow model. We define it with the path we have here with our saved model. We define the framework version, and we deploy it with one line of code. And I've already done it before, so you see that it took 8 minutes to build this model, to deploy this model. And what happens in the background is that SageMaker builds 2 parts here. And I will show you that here. This is our console. And here we see we are in the SageMaker. And the most important part is that is being built by this line of code is the endpoint configuration. So this is not a deployed model. This is an endpoint configuration, so our model configuration. And by having this, we can then just easily rebuild our model. So we can just stop the deployment, but then we can come here tomorrow and just start it again. So this is the most important part for reusing this deployment. But exactly this, so this line of code deployment does this, and it instantly uses this to create an working endpoint. So we have right now in-service endpoint here. Let's look at that. We can see some details here. When was it created? What instance is underlying? How many instances we have here? And what is the model name? Of course, it points to some real model artifact. So in S3, we can find, go here. In S3, we can find this model artifact. So it is a real TensorFlow model lying on S3, underlying. And with this endpoint, we can just, this is a deployed endpoint, so we can right now use it. So as you see here, I just create some random input for this model. And right now I have this predictor here in this variable. So I can just run prediction on this model, and I already got predictions. So sorry for not formatting it, but you see that we have outputs and some classes from the ResNet probably returned. So this is it for deploying TensorFlow in SageMaker. Here we have just we could also just see what kind of classes are here. This is an ImageNet model, so we have labels from ImageNet. We can just match it and then see what kind of label was classified here. It was a tub. But also the next question would be, okay, but we have it in SageMaker right now here, but then I will just delete this notebook, but I want to reuse this endpoint. This endpoint configuration that I have here. So for example, I will stop this model. I don't want to pay for that. So I stop it and then maybe I come back week afterwards. So I only need this configuration name, which was here. And in few lines of code, I can, with using Boto3 and SageMaker client, I can just point to this endpoint configuration and create endpoint again, just from this endpoint. And again, the next question would be, okay, but we saw how we can just do prediction when I have this variable here. So I already got this, the deployment, I can just communicate because it was returned here to this predictor. But let's say I'm in another notebook and I want to use this endpoint I deployed. This is also very easy. So when I have my endpoint name, so, okay, so this is my endpoint name. So to be clear, this was endpoint configuration name, and here I have my endpoint name. I can just reference, I can just use the client runtime client from SageMaker from Boto3. Again, I have some random input. And with the client API, I can just invoke endpoint by its name. I format it as a JSON input, and it just returns me the input. It's easy as that to deploy TensorFlow model. Let's go to some other example I wanted to show you. So here we have an example with a hyperparameter tuner. Again, we don't need any external libraries, and when we want to do it fast. And also the specific problem is that usually when people have some prototypes or some POCs, they know that they are pretty sure that it should work, or they want to make it more automatic. They want to build some pipeline. And they don't want to spend time on building all those steps. So with SageMaker, you can easily build this deployment, build this pipeline. And also when people want to do automatic retraining, they also want to be sure that hyperparameters are tuned always when the model is retrained. So again, it's very easy to do here in SageMaker. So here we have some finance data. Let's not focus on the data itself, but let's just look what we have. This is a binary data. So the answer is yes or no. And we have some data points on persons. So job, marital status, education, and some numerical data and so on. And then binary decision, yes or no. So a simple model, we just do some, let's not focus on that. We do some data preprocessing. We build our training data. So here we have our training, validation, and test data, and we upload it to S3. So we are ready right now to do the pipeline thing, right? Because we just ended our data science thing. Right now we're trying to make training more easy. So here we do it with XGBoost model. This one is pre-built model in SageMaker, but you can also use some different version of XGBoost. So we define our XGBoost estimator. So this is the most important part here. So we have the estimator, and this is our object with training model. And we specify hyperparameters we want to tune. Right now, the hyperparameters for the model, but later on we want to tune them. So normally, oh, this is a copied code, sorry for that. So normally we just specify, again, for the training, we specify like this training input. So we have train and validation here, and we just fit a model, and this trains our model. So easy as that, something similar to scikit-learn API, nothing complicated. But then we want to do the hyperparameter tuning. So we have, for different parameters, you see we have different parameter ranges. So here we have continuous parameters, here we use integer parameters. Don't remember exactly what other types we have. Okay, we have categorical parameter, and that's it for here. I don't remember the full scope of other types, but you see that we can tune many types of parameters. So here we specify the ranges for different parameters. This is our ranges specified. And what is our objective metric for this tuning? Here we specify the hyperparameter job. And again, just as for the training, we specify those paths for the SageMaker, and we use the same API for tuner as we did for the model itself. So you see this was just fit. And here again, we have just fit. And I also run it before our presentation here today, so we can see the results. And again, let's jump to the console. It should be here. And we have May 19. So you see that there were 20 training jobs run on 20 planned. It took 29 minutes, sorry. And here we see exact details on every training job that was performed there. So we can see what was the objective metric. So we can compare it easily here, how time each training job took, but also when you go to training jobs here, the same training jobs will appear here. But here there are reference to the hyperparameter tuning job. So for each training job, we can, of course, again, go to this model and see where it lies in S3. But sorry, it was the path to validation, but we can also reference the model somewhere here. Yeah, this is the model outputted. So everything is accessible and everything is monitored. And here we have the best training job. Again, what was the and what were the parameters? But we don't have to. Here it's just for the presentation part. But we can also, when we make it automatic, we don't want to look at those things. We don't necessarily have to see what were the chosen parameters, but we want to deploy it. And just by running again the same as we run it with normal SageMaker model, we just run tuner deploy, and that's it. Our model is deployed just like the model before. So when we imagine make it automatic in our pipeline, this is just defining hyperparameter ranges, defining hyperparameter tuner, and fitting. So doing the hyperparameter tuning and then deploying. And that's it for deploying model that was tuned in case of the best parameter, in look for best parameters. Sorry about that. Just a quick look here, because for me also what is important in the high-level AI services is that when I also mentioned the high-level services, it's often the case that we don't have skills in our team because we focused on a specific area of machine learning or deep learning. And let's say, for example, we want to build some additional features on image recognition. We can just easily use in our API, we can just import recognition from the Boto-free library. Let's skip that because here I'm just iterating some bucket with some images. This is an example of image. And by recognition detect labels, we can have quickly our images labels here detected. So you can imagine that, for example, you can use it as a feature to some personalization, to some tabular data model, something like that. There is a label detection here, for example. Sorry, this is label detection, but we can also recognize this is some image with text, and we can here we use detect text method. It is returned with some with the coordinates in the image, so we can also localize where the texts are. And so this is example. You have this poster here, and everything is recognized in this places. So even you see the first one is lookup, and this was recognized here. Yeah, something which was weird for me at the beginning was that here, for example, you see this is in a series of airmail pickup, and where was this New York recognized? And this is because this was this line, and this was NY recognized on the wing of the plane here. This is how the recognition works. Yeah, you can, for example, count some birds on images or count people on images, also using recognition for that. So also something, it's when you want to build something more complicated, usually you would make it custom, you would build it in TensorFlow. But when you want to do it fast, you want to add it to your models, you can do it with few lines of code using recognition, personalize, forecast, transcribe, comprehend, or anything like that. This is to help you. Let me just show you two more things very fast. We still have 7 minutes. I think we can just also fit this. This is an example of how we look on the SageMaker like data science pipeline philosophy. So again, the problem, you are training your model, and you know that you pay for the training. Maybe it's a very heavy and costly model. And you know that sometimes something happens during the training, and you don't want to then this training to continue because you still pay for that. So it doesn't have to necessarily work again for 2 weeks, because after 2 days, it can be debugged that it shouldn't be work. So this is exactly what is like you can compare it to the early stopping philosophy. So it's often implemented in many frameworks. So early stopping. So when you see that your loss is not decreasing for a few epochs, the training just stops. So some metrics, some observations are made during training, and according to those observations, the training process stops or continues. This is the early stopping philosophy, but SageMaker Debugger is just a tool to build such things as early stopping. So let's again skip the code, which is not important for us, but let's just look that we have some features like age, work class, education, again, marital status, country, stuff like that. We prepare the training and data and training and test set. And what is important here, so again, you see that we do everything the same as usual. So we define estimator, but here, what is extra is that you add this debugger hook. And what it does, you just defined what should be saved on iterations of training. So we have some feature importance, for example, on every iteration, SHAP values for the features, and other metrics. And so this is the basic. So we say to SageMaker that it should just monitor what is happening in training, though, in those dimensions. But here we also can add rules for that. So a part of monitoring the process, we can also add rules. We can also add custom rules, but there are many predefined rules. So this is exactly the simple rules that if loss is not decreasing, we should stop our model. And this is exactly that. So we run training model training here. We run the training here. So we have the training jobs, and rule evaluation was done. So training was not stopped here. But we did monitor everything during the training. So the debugger was saving the artifacts. And here we reference those artifacts. And we have those dimensions we wanted to monitor during the training saved here. So again, just skipping the boilerplate code, we can then monitor our training and validation error. We can monitor our feature importance. We can monitor our SHAP values. Here it was done just after training. So we look on iterations, but it can be done in the same way during the training. So you can also imagine that this is something similar to what we get in TensorBoard. But TensorBoard, of course, is a great tool. Also use it. But if you want to implement something more custom for some different models, and for example, TensorFlow models, you can reuse debugger here. And one last thing, we have just 3 minutes left. So let me also just show you quickly the monitor. Again, the first fast problem it can solve that you have your model deployed and somebody asks you, okay, so we will need all the predictions to be saved somewhere. So what was the input to the model? What was the output to the model? So this is like the basics of the model monitor, what it does. Then we can do something on that, but this can be done very easily in model monitor. Again, let's keep we define paths here for the model. We will be having charm prediction model XGBoost here. Again, we have our model definition, and we want to deploy the model. And before deploying the model, so here we have the endpoint we've prepared before. And before we deploy the model, we create this, so data capture config. So this is exactly this. We tell SageMaker, okay, so save every input with its output for us. You can define, for example, sampling if we want to do it for every prediction. If we have a huge traction, we want to maybe sample a little bit, not taking all of that. Okay, so right now we are running this real-time predictor. Here I just run some loop to make some flow of data, to make some predictions. And here we reference what was captured by the SageMaker. So there is a capture file from the model in production, and we see here what was captured. So here it's more formatted. So let's look. Capture data endpoint input. So it was a CSV file. Those were features that were input into the model. And this is endpoint output. This was the returned value, also in the CSV. And we have some metadata here, like inference time, when was this run, and the event ID to differentiate. So you see, this is this is not very complicated. There is, it's very simple to just have this requirement of monitoring the model. But the case we're having is that we make it really, really easy to add. Just with that, you just have this monitoring done with inputs and outputs. But one last thing to add on that, we can add some monitoring. So we can add some logic that exactly looks on those logs and does something. So looking on our training data, we can use the feature of suggesting baseline. statistics on our training data. And SageMaker will look in our training data and will show us some statistics around our data. So some mean, some statistics, what were the formats, and so on. And based on that, it will suggest constraints. So here it's just suggested that numerical values should be positive, because in training data, it looks that all values are positive. We can do our own constraints, but also SageMaker will suggest its own. So it suggests constraints for the type here, and that all numerical values should be non-negative. And then again, I will just skip this code when I run the test endpoint with this monitoring running in the background. And when the monitoring runs as a cron job, so for example, hourly, and then I can look what was its output. So you see here, for example, that it found some violations, and that expected data type was integral, and expected it was in 100% of data, and it was seen only in 99.67 and something percent. So not all data is integer, and it will be monitored in by the monitor. You can imagine how many things we can add here. So any date drift, any problems with the data that comes in. So for example, there was some format change somewhere, something changed in preprocessing code, something in the data collection changed, some bias we can also monitor here. So you can easily add it to your deployment part with this model monitoring feature and be more safe with what's happening with the model itself. Okay, I think that's it as for the demo codes and from myself. So thank you very much for your attention, and maybe we still have some time for some Q&A. So let's maybe have some discussion. I will stop sharing my screen and handing over to whoever wants to ask some question.
Yep. Thanks a lot, Łukasz. That was great. If you want to ask a question, you can do this through that Q&A panel, or you can just raise your hand in Zoom, and Marcin will grant you the mic.
Okay, so I have. We see that there was a first question. Can the presented tools be used when training is done in high-level services? Amazon Transcribe, for example, and the answer is no, unfortunately. So this is the case where we have to choose between the flexibility when we have this lower layer, when we use everything, and the high-level services. So I personally use AI services when teams lack data science skills, and this is when we propose them. So when there is data science skill, I would recommend using SageMaker, because then you can do everything by that, but not in Amazon Transcribe or Personalize or anything like that, unfortunately. But depending from the service, and but not in Amazon Transcribe, because Transcribe also is already a trained model, you just use it. But for example, you train models in Forecast or Personalize, and there those services gives you some ability to, for example, look on metrics or to do some hyperparameter tuning. So it depends from the service. Next question, which deep learning libraries besides TensorFlow does SageMaker support? PyTorch. It's all major. So PyTorch, TensorFlow, MXNet. I'm not sure what else, but I'm sure about those three. And we really struggle to support all those three very wide. So for example, also, previously we discussed with Adron a very important thing of training models simultaneously. So on, sorry, I lack words right now, but training models on many machines, on many instances to have this process done faster. It's all prepared to be done the same as you would do it in TensorFlow or PyTorch. So yes, so PyTorch definitely. Next question was how SageMaker compares to EMR. Can we use distributed computing like TensorFlow distribute package? not sure if we can do it, use TensorFlow distribute package. And I would like to maybe the person who asked this question maybe could clarify on what would be the comparison point. So what would you like to compare as for how SageMaker compares to EMR? Okay, if we don't have the clarification, I can just maybe also expand that what I just.
I think we do. It's actually Adam. Well, Martin, would you be able to grant Adam the mic?
Yes, sure.
Ah, he's got no mic. Sorry, he may be. Yeah.
Does it work?
Yeah.
Yeah, okay, I was muted. Classic. Yes, for example, if you are using pre-processing in Spark cluster because it's very big data, and then you somehow want to train it, but it doesn't really fit into one notebook. No. Can you then distribute the machine learning part as well?
Definitely. So this is exactly what we do in, I don't want to pronounce it wrong, but it's data parallelism library for SageMaker. And you can, if you have the problem that the data set is too big or the model is too big, you can easily use the parallelism library. And this is exactly what I said, that the advantage is that it gives you the parallelism. It has the same API. You can use the same API as you would use for Horovod with TensorFlow, for example. And also you can use the same API, which there is this library for PyTorch. I don't remember the name, but you can also reuse the same API. And also the advantage is that it's built with SageMaker, and usually everything in SageMaker is optimized for the underlying instances. So when you would compare just pure Horovod implementation, for example, it will be less effective than the SageMaker parallelism library in this manner. So yeah, it's quite, and also it's written in the way, also as I was showing the SageMaker debugger and monitor, it's written in the way that you can just easily inspect your code that you used for your single instance for a smaller model, and you can just, I think there is something also, some helpful tool that can just show you points in the code where you have to change something. And the process is very easy to make it more distributed.
Okay, thank you.
Next question, does hyperparameter search use any optimized algorithm to select sample hyperparameters to runs? Or are those just sampled randomly? Yeah, this was something we discussed shortly in the beginning. So there are two ways. There is a random search and there is a Bayesian search. Both has pros and cons. So the answer to your question would be Bayesian search from this choice. And this treats hyperparameter search as a regression problem. So it learns on previous iterations and sometimes try to find something which was close to parameters that was the best in the last iteration, and sometimes it will just try something very different to explore new options. So this is the most useful if you want to do it cost effectively. So with smaller amount of iterations, because it has a more informed way of doing that. But we have also the simple way, so the random search. And the random search has this advantage that you can easily make it parallel. So you can do many jobs in the same time. So for example, if the speed was critical, you can just do 10 jobs in the same time and do this tuning much, much faster. You saw that in my simple example for 20 jobs, it was 29 minutes. So if the time is critical, you would go with random search and with simultaneous jobs. in the background. Another question on the second slide of your presentation, you mentioned several AI services implemented on AWS, including the Lex chatbot service and speech processing service. Do they support the Polish language for this moment? Unfortunately, no. As a Polish-speaking person, I also just, I'm very sad with that, but still no Polish language support. But this is a problem of all NLP, right? That we want to reuse some popular libraries. We have to wait for support for this specific language. So yeah, sorry, but not yet. Does endpoint autoscale? Endpoint does not autoscale, but you can configure it. So it's not automatically made, but you can configure it for to make it more autoscaling. Maybe I can just also point you to some reference on how to do that. So of course there is a choice in the beginning. We make a choice which which instance underlying we want to choose, right? The bigger instance is in case of memory, GPU, and so on. But you can also create many endpoints at once. But you can also prepare some autoscaling policy for that. I have a question about ML explainability. I saw an example in your demo of SHAP values and feature importance using a debugger. Are these metrics also available in high-level services like Amazon Personalize? No, unfortunately. So again, this is the first question. This is exactly why we built the SageMaker, to have something in between. So also when you think that you have those high level services to get to the point B very fast, you have the effect very fast. And this is why we have many built-in algorithms in SageMaker. So for most of the problems we solve with AI services, you have some built-in models in SageMaker. So this would be a route to take some pre-built model in SageMaker to recommendations, to forecasting, to anything, to computer vision, and then use the SageMaker debugger or SageMaker monitor with that. And this is the general recommendation. So whenever you want to use, when you have data science skills, so you understand what is SHAP value, for example, this means that you should go with the SageMaker route. So get pre-built container, or you can also SageMaker support some custom containers. So you can also get some TensorFlow NLP container and anything like that, and build it in SageMaker and have all those monitoring, debugging, feature stores, everything for yourself. Yeah, so this would be the way. But again, no, sorry, AI services don't have those features. Okay, I think we are perfectly on time, and these are all our questions in the Q&A.
Yep, perfect timing.
Yeah.
That was great, Łukasz. We will definitely look at SageMaker, I'm sure, just to compare it with what we're doing right now. So thank you very much. We'll put it online. We'll send you a link, and it was great to have you here.
All right, thank you for your time, and let's keep in touch then.
Thank you.
Thank you, guys. Take care. Bye.